If I told you that rockets don't work by pushing against air, would you believe me? Most people think they understand rockets. They burn fuel, push against something, and up they go. Except that's completely wrong. In fact, rockets work better in space where there's nothing to push against. That sounds impossible, but by the end of this video, it'll make perfect sense. We're going to blow your mind with the real physics behind rockets. And trust me, the truth is way cooler than the myth. Let's start with the biggest misconception that even educated people get wrong. When you ask someone how a rocket works, they usually say something like this. The rocket shoots exhaust downward, pushes against the air or ground, and Newton's third law pushes it upward. Sounds logical, right? There's just one massive problem. If rockets needed air to push against, they'd be useless in space. But in 2026, we've got rockets delivering cargo to the International Space Station, satellites orbiting in perfect vacuum, and missions to Mars in development. All of this happens in the vacuum of space, where there's essentially nothing to push against. So what's actually going on? Here's the mind-bending truth. Rockets don't push against anything external at all. Instead, they work by throwing mass in one direction, which propels the rocket in the opposite direction. It's all about momentum. Think about it like this. Imagine you're standing on a frozen lake wearing ice skates. If you throw a heavy backpack in one direction, you'll slide backward in the opposite direction. You didn't push against the ice, you pushed against the backpack. That's exactly how rockets work. They're continuously throwing mass in the form of hot exhaust gases out the back. The rocket and the exhaust are one system. When you accelerate the exhaust backward, conservation of momentum forces the rocket forward. This is Newton's third law in its purest form. For every action, there's an equal and opposite reaction. But here's where it gets really cool. The action and reaction aren't between the rocket and some external medium. They're between the rocket and its own exhaust. The two parts of the same system pushing against each other. This means a rocket carries everything it needs to generate thrust. The fuel, the oxidizer, and the combustion chamber. No air required. No ground required. No magic required. Just pure physics. Now let's talk about what really determines how powerful a rocket is. It comes down to two critical numbers. First, exhaust velocity. How fast are those gases shooting out the back? Modern rocket engines can reach exhaust velocities of 4,500 meters per second. That's more than 13 times the speed of sound. Faster than a rifle bullet. And it's all happening continuously. Second, mass flow rate. How much exhaust are you throwing per second? The Saturn V moon rocket burned 3,000 kilograms of propellant every single second. Multiply exhaust velocity by mass flow rate, and you get thrust. That's the force pushing your rocket towards space. To maximize thrust, you want the highest exhaust velocity possible and the highest mass flow rate you can manage. Simple math, insane engineering. But here's something that'll blow your mind. Remember when I said rockets work better in space? On Earth, atmospheric pressure is pushing against the exhaust trying to come out of your rocket nozzle. It's like trying to blow up a balloon inside another balloon. In space, there's no atmospheric pressure fighting your exhaust. The gases can expand completely, reaching their maximum velocity. This is why rocket engines are rated with two different thrust numbers: sea level thrust and vacuum thrust. The vacuum number is always higher. The SpaceX Raptor engine, for example, produces 230 tons of thrust at sea level, but 258 tons in vacuum. That's a 12% boost just from removing atmospheric pressure. Same engine, same fuel, more thrust. This is also why rocket nozzles have that distinctive bell shape. They're designed to expand the exhaust gases as efficiently as possible. But there's a problem. The ideal nozzle shape is different at sea level versus vacuum. This creates an engineering nightmare. Some rockets use shorter nozzles optimized for atmospheric flight. Others use longer nozzles for vacuum efficiency. You have to pick your battles. This is why modern rocket design in 2026 is so fascinating. Engineers are getting creative with solutions. SpaceX's Starship uses multiple engine types. Sea-level Raptors with shorter nozzles for launch, and vacuum Raptors with enormous nozzles for space. Some experimental engines even have extending nozzles that deploy in space, like landing gear for your rocket exhaust. The physics is simple momentum transfer, but the engineering to do it efficiently takes decades of innovation and billions of dollars. And here's the beautiful part. This same principle works everywhere. On Earth, on the Moon, on Mars, in deep space. As long as you can throw mass in one direction, you can move in the other. That's the fundamental secret of space travel. So the next time someone tells you rockets push against air, you can blow their mind with the truth. Rockets are momentum machines. If this changed how you think about rockets, smash that like button and subscribe to your Space Wizard. We make the universe accessible, one mind-blowing video at a time. Now you understand the real physics that's taking humanity to Mars and beyond. The universe just got a little less mysterious.